often called the cardiovascular system. And it's made up of 3 different kinds of blood vessels: arteries, veins, and the little tiny ones, the capillaries. Oh, I think they're also called capillary beds, just capillary nets. They look more like a net than a bed to me. They call them capillary nets. Yeah. So this is the single circulation system of a fish. It has a 2-chambered heart made up of a atrium and a ventricle. The vein carries the blood to the heart, and the artery carries the blood away from the heart. And you don't have to remember that part, the veins versus the arteries. That's perfectly suitable for an advanced class. So what happens is the blood pumped out of the heart then goes to the gill capillaries over this counter-current exchange mechanism to gain oxygen, turning the blood red. And this actually does happen. The blood actually does get red. It changes color when it gets oxygenated. Yes, you can see it. You can see the blue veins in your body. And actually, have you ever wondered why you can cut yourself and you see a blue vein when it's under the skin, and then you cut yourself but the blood's red? There you go. Smarty pants. Okay, did you guys hear that? The blood touches the air, gets oxygenated, and turns red before you can even see it, the blue part of it. Okay, so anyway, where was I? Yes. So around the gills, we have the counter-current exchange mechanism. It oxygenates the blood, and then it goes. This is called the gill circulation. So that's part of the circulation that's to the gills. It oxygenates the blood, and then it goes throughout the rest of the body and to these capillary nets or beds, which then, and this is called, there's a number of these systemic capillary, there's a number of these capillary beds through the systemic circulation. And that's all of the places where the oxygen is transferred from the blood to the different parts of the body, and that's called the systemic circulation. And then the oxygen is transferred, the carbon dioxide is picked up, and it's taken through the vein into the heart ventricle, and then to the gills again to drop off carbon dioxide and pick up oxygen. The higher vertebrates have what's called double circulation, meaning the blood will actually go to the lungs and then come back to the heart before it goes out to the system. And then it'll go out to the rest of the system, drop off the oxygen, and then come back to the heart again. It's more efficient that way. And this first picture is amphibians. If the blood goes, the anoxygenated blood comes from the body into the right atrium, down into the ventricle. Amphibians just have a 3-part heart, 2 atria and 1 ventricle. Okay, so it goes into the atrium, then down into the ventricle, and then out into the, what's called a pulmocutaneous circuit, where it goes to the lungs and the skin, because amphibians can breathe through their lungs and through their skin. So here are the lung and skin capillary beds. They drop off the exhale and diffuse through the skin the carbon dioxide, and they take in the oxygen, and then the oxygenated blood goes back through to the heart, through the left atrium, and then down into the ventricle. And you can see there's this purple part here. So there's actually some potential mixing of oxygenated and anoxygenated blood. And so when that happens, most of the oxygenated blood goes out here through this through the ventricle, out here, and down into the rest of the system, the systemic cap, and then off gets the oxygenated blood, drops the oxygen off to different parts of the body, different organs, and then it picks up the carbon dioxide where it goes, and then it goes to the heart, and then out to the lungs again. So as we get up in complexity, sort of the advanced, the more derived condition is the more efficient condition at circulating the blood. So this is a three-chambered heart. All reptiles except for birds also have a three-chambered heart, but there's a septum here. It's a separation that goes and almost closes up the ventricle completely, okay, but not quite. And because of this, it actually has it has an extra aorta here that takes the mixed blood. And I'm going to go over this again on Friday because this is complicated and I don't want to just do it in 5 minutes. But it actually, so it still has the same, pulmonary circuit and systemic circuit here, the double circulation. But it has a second input to the systemic circuit that takes this blood that gets mixed, the anoxygenated and anoxygenated blood, and moves it back into the system so they can get all of the blood, all of the oxygen out of the blood. So that's a little bit of a derived system. In mammals and birds, they actually have a 4-chambered heart. This septum right here is now completely closes off the what used to be one ventricle and makes it into 2 ventricles. And so, whereas this is not this is 90% efficient, this is 100% efficient, unless, and actually that closing of that, this is another example of how we sort of go through our evolutionary stages when we're developing embryos. Some babies' hearts don't have the septum that goes all the way up, and some of them, if a baby's born with a hole in their heart, it just means the septum hasn't completely closed off. Like a healthy 2-term baby's heart should be totally closed off, and the baby should have 4 chambers. And that's, one thing that people, that babies, they can get fixed. They can have heart surgery for that. Yes?
So 2, 3, 4 chamber. That's what we're looking at.
3, 3, 4. Yes. The fish has a 2-chamber. So I have a whole nother lecture to give at 20 after, and I'm starting to lose my voice, so I think